Right, let's get started. Hi, everybody. Thank you for joining us for this early session, waking up for us both online and here in the room. I'm Dean Andrews. I'm head of developer relations at InterSystems. I'm going to give you a brief overview of InterSystems, tell you a little about our developer resources, and I'm going to pass it over to Frank and Patrick for some tech demos. We only have 30 minutes, so I will be brief. You may not have heard of InterSystems, but we have been quietly powering the healthcare industry for over 40 years. We currently have customers in over 80 countries and support over 1 billion patients with our technology. If I was to put it into a nutshell, I would say InterSystems helps supply healthy data for digital health solutions across our industry. For example, every Epic EHR has InterSystems data platform at its core. Similarly, for providers, both regional like Providence St. Joseph Health and national like Scotland's National Health Service and the US Veterans Administration, InterSystem powers their technology efforts through our HealthShare, TrackCare, data platform products, and also our newer FHIR Cloud service. We also support payers. We support medtech companies producing IoT and life sciences solutions like Roche. We also support health information exchange networks, HIEs, across the country, and we interoperate data between all of these entities. US News and World Report has a list of an honor roll of the top 20 in healthcare, and all of these organizations are InterSystems customers. Now, if we focus in for just a second on one of our products, HealthShare Health Connect, what is it? It's an integration engine that delivers high volume transactions, process management, and monitoring for mission critical systems. It's also a powerful bridge for data between legacy standards and FHIR. And it has many advanced capabilities like API management, device interoperability, cloud offerings, and more. We take pride in InterSystems of solving problems for our clients. These are just a few examples. This is why we've been in business for 40 years. FHIR is an integral part of our healthcare technology. If you search on InterSystems and FHIR, this will be one of your top results. There's information here for developers that are new to FHIR and also those who have years of experience. You'll find articles, explainer videos, sandboxes where you can try out our technology, and then there's more advanced information like device integrations, information on AI and ML, and so forth. We have a very strong developer community at InterSystems. There are over 12,000 developers from around the world active in our community. There are many different assets to it, and it's also, all the resources are available in 6 languages. I'll just touch briefly on two components today. There's a central hub for our developer community, a forum. Again, there's information here for developers new to InterSystems technology and also those who have used it for years. There's articles, there's a very large Q&A area, there's news, there's code samples, code challenges, and more. And again, it's available in multiple languages. We have an open source app gallery that has over 600 applications. We just added 22 last month. It's all accessible via GitHub. There's a package manager system involved as well. It's a great resource. We believe in innovation in InterSystems, both internally, which you'll hear about in just a second, and externally as well. We have hackathon programs and a startup accelerator program. We've participated in 5 hackathons so far this year and plan to participate in 4 more before the end of the year. We're going to expand that number next year. We also have an active startup accelerator program in Europe right now. It started in March of this year, ends in November. We supply mentoring, support services, free access to our technology. There are 22 businesses in there now, and we're going to replicate all of this with a startup accelerator in the United States later this year. Let me pass it off to Patrick now. Thank you for listening. We'll save the questions to the end.
Thanks, Dean. I'm really excited to be here and share with you some of the innovations my team at InterSystems has done over the last year in trying to make analytics easier for FHIR data. My name's Patrick Jamieson. I'm the product manager for IRIS FHIR Health, and I'm going to talk to you about a feature that has not been released that we plan to incorporate in our data platform called IRIS FHIR Health for not only doing, for principally doing FHIR analytics. So let's talk a little bit about FHIR analytics in general. Why would you want to do it? And it basically comes down to the same reasons that you would perform any healthcare analytics. You'd probably are interested in doing studies for population health. Maybe you want to manage the risk of a population or do risk adjustments for a defined population. Healthcare quality reporting, that's a use case that we see not uncommonly. Public health surveillance. And then people want to build anonymized research data sets or do machine learning and do predictive analytics and HEDIS measures. So there's all kinds of reasons you'd like to use the information that you're accumulating in your FHIR repository and then do some kind of analytics on that data. So what is the problem? Why can't you just do this fairly simply and easily? Well, the problem is pretty simple to state. FHIR is a complex directed graph. It is not relational. So there are a variety of approaches that you can take the data in a FHIR repository and then do analytics, but they don't use in general the traditional ANSI SQL language that you may be familiar with. Whoop, went a little too far here. So, doesn't like that slide. I was going to show you what is inside a FHIR repository. And it's advancing. Basically, in most FHIR repositories, what you have are structures that store JSON as strings inside the repository. So a resource may be stored as a string. Clearly, trying to extract information and do things like joins would be very difficult operating on these types of strings. So our vision was to create a sophisticated projection tool to help developers create their own custom SQL schemas using the data in their FHIR repository and make that transform FHIR data into relational tables inside our platform, IRIS FHIR Health, which has a high-speed multi-model database. Let me show you the steps for doing this because I think they're fairly simple. The first thing this tool does is it analyzes your FHIR repository and it understands then all the resources, elements, and other data structures inside that repository. It then displays for the builder or the data steward all the resource and elements counts. So you could get a great understanding of what you might want to project. From that, we obtain the selections by the user, because there may be things that they would like to include in a specific schema. But in reality, in a typical healthcare institution, they may want to build several schemas. So some schemas might have certain data types and or FHIR resources, and other schemas would have different resources. Then we generate SQL projections. And I know I've gotten questions about this in the past. Why project the data? Part of the reason is that you don't want to duplicate the data in the FHIR repository and move it to another, let's call it an analytics repository. That incurs some cost in terms of storage. You have now really 2 copies of the data. But more importantly, you also there's going to be a time lag in copying that data and moving it. So the most efficient way is really operating on the data itself. But again, FHIR data is non-relational, so that makes it difficult. After data is projected, users then can edit these schemas. So you're not locked into using what you have at any given point in time. You could always change it. What makes it possible to do projections, as I'm explaining, is the fact that we have a multi-model high-performance database. We call it translytical. That's actually Forrester's term. It really allows you to take data and view it in several different ways, including relational. So at this point, I'd like to give you a demo of this. This example really is just came up in the last week. A sales engineer called me and said, hey, how would I get all of the medications for a given patient? How could I do that? What kind of query would I write? And I said, well, that is a fairly simple include query. You could easily do that. But in terms of building an application that would then show you the medications for any specific patient, of course, you'd have to do all the extraction of that data from the JSON strings that would be returned in the query. So let's see how we can maybe accomplish that a little bit easier using the FHIR SQL Builder. So here I'm showing you the main screen. I'm not going to perform an analysis because our time is limited. I'm going to go right to building a transform. And so here I'm going to build a new transform. Let's call this transform number 5. And we'll base this on an analysis that I did some time ago. So I'm now going to create a new transform specification. And you'll see on this left side, I have the element of the resource counts of all the resources in this small repository. So I could see that there's 33,843 observations. And I could see also the elements for each of the resources. So for patient, for example, there's 115 patients, and now I can transform metadata last updated, the FHIR path expression, to just last updated. That's what I want to call it in my SQL schema. So let's go ahead and select some additional things. Let's select gender. That would be very easy to project. And let's take a look at birth date. Okay. I'm going to look at extensions now. So here I want to get the patient's birthplace. That is an object. I could project those as columns, or I could project that as a separate table. I'm going to just project them as columns. So here I'm going to rename this column patient address city with the extension equal to the URL that I want to select. Essentially, it's a FHIR path expression, but you notice you don't have to type any FHIR path. And the same thing, I'm going to do this for the state. I'm going to, again, change the name of the column to make it a little more intuitive. Add that to the projection. And I'm going to take a look at name. Now notice name is an array of names. There's 2 repetitions. I'm going to only want to use the official last name, and I'll show you how to do that. I'm going to type in last name, and now notice I could select through the GUI a restriction or a filter, so I'm only filtering on the official last name. I'm going to go back to gender just to show you another feature where you can actually see a chart or graph of what is in the repository, so how many females or how many males. You could do this for every one of the value types that are selected. So now let's go to medication, because we want to ultimately link the medication to the patient. So I'm going to select then the subject reference because I need a linking key. And I'm going to go ahead and I'm going to select the code. So again, these long FHIR path names I'm going to change just so I can make it much easier to do queries. And you could see here's a bar graph of all the codes in the system. And then finally, I think I'd want the display name because I want to have a very simple way of seeing the names of these medications. So I'm going to change this to medication display. All right, once that's done, I could go back and edit these things, but I'm going to select this. Now I'm ready to project that data as a schema in IRIS. So I'm going to go ahead and make a new projection. I'm going to use our demo FHIR repository. I'm going to use the transform I just built, and I'm going to create a new package to place my schema. I'm going to put this in SQL 5, and I'm going to launch that projection. So now I could go directly to IRIS, and I could do queries using this projection. It's all ready to go. I'm going to select the SQL 5 schema package that we just made. And I'm going to go and take a look first at the patients. And you could see we have all the columns that we selected here that we just did in the transform spec. So we could see all these columns. And let's take the medication request. And you could see again, we have all the columns that we just made, and that's all projected as SQL. So basically, you could use standard ANSI SQL to look at these tables. You could also do joins, and that's what the sales engineer was interested in this case. So I'll paste in a query, a join query, and again, execute this. And again, using these projected tables, now I could join the two together and provide a much easier way of showing, well, what medications and their statuses for a given patient. So that's kind of a very whirlwind tour. If you want to learn more, I'm giving a longer version of this talk tomorrow from 11:10 to 11:30, and I'd be happy to take any questions. But I think you'll enjoy doing FHIR analytics, whatever tool you have. I think you'll find that projecting the data makes it easy to use your standard tools like business intelligence tools. And again, thank you very much for this early hour and coming out. Now I'm going to turn it over to Frank, who will talk about another innovation at InterSystems. Oop, oh, it really has a mind of its own, Frank.
Sorry.
It seems to advance no matter what you want.
All right. We'll take some questions at the end. Thank you for coming and showing up. My name is Frank Pandolf. I'm a product manager at InterSystems. I'm also a practicing clinician as a hospitalist. And I want to talk to you about our product that we've been working on. It's now in beta release. It's called the HealthCare Action Engine. And it's really a solution to help with a CDS hooks implementation and rollout. So as you can see, CDS hooks really just defines the interaction between a client and a service endpoint. And it leaves it up to the implementer to define how these services or rules are written. And that's really actually one of the difficult parts. In addition, the CDS hook spec defines a number of security protocols, signing algorithms, and all sorts of other things that need to be sort of set up, like discovery endpoints, service endpoints, feedback endpoints. So there's a lot of overhead actually in getting a CDS hook service up and running. So, the intention is really to be able to quickly deploy these services, but if you really want to do it, there's a lot of infrastructure that you even need to deal with before ever, touching the content that you want to create. So the goal is really to decrease that overhead and make it easy to create and deploy that content. Obviously one of the benefits of CDS hooks is that you can write one rule and then deploy it across a number of different institutions and applications. So, as long as a client supports the CDS hooks client spec, then they can just call into a server, run that rule and get the results in real time. So that means, for instance, when there were COVID rules that were being written, that information is changing rapidly. So if you're an administrator across, an institution that has different EHR vendors, you have to write that rule in each platform. You have to test that rule in each platform. There's a lot of administrative overhead in getting that done. The beauty of CDS hooks is essentially that you can write that, point it to a FHIR endpoint or the native FHIR endpoint, and get that rule tested and deployed quickly. So as I mentioned, some of these barriers to implementation is really the security. Knowledge management is another issue. So there are rules that are written, say, in a EHR specific platform. There are rules. You may have several different CDS hooks vendors and rules that are written by different applications that you want to integrate. There may be different rule engines. So, we have a native rule engine, but there may be a CQL rule engine or BPM plus or, something else. And, you don't want to have to necessarily go into each one of these applications, have them use their own CDS hooks implementation. So knowledge management is also a big issue with trying to deploy and organize all of these rules. And I just want to sort of point out that support is not necessarily a solution. So a lot of vendors will say, well, we support CDS hooks, but what does that really mean? I mean, a river supports having a bridge built, but that doesn't necessarily mean that it's very easy to do it. You still have to build up all that infrastructure. So this is really a solution to help you get that product out. The other issue is rule authorship. So to write, say, clinical decision support rules, there is a team that needs to do that. That needs content experts, analytics people, as well as software engineers in order to finally write those rules and test them. So, one of the big barriers to, again, getting that content out is actually the software developer. To be able to write those, you need to have a big enough institution to support that kind of infrastructure. So we help with rule authorship, and I'm going to show you a demo that shows you how we accomplish that. And then obviously FHIR versions and profiles is a difficult thing to deal with. The client and the server have to match in what FHIR version they are and if there's any profiles. So I'm going to show you the demo, and hopefully this works. We'll step through it. So this is the action engine, sort of the splash page, and you can see that we have a number of different libraries. So we have libraries for triggers, rules, and cards. There's also, settings where you're able to set up your FHIR endpoints, some of the stuff for CDS hooks allow lists. So in the triggers library, you can see that, we support all the standard CDS hooks triggers. And then in the rules, I'm going to show you how we edit and build a rule. So this is a CMS rule that is patients over the age of 18 should be on an ACE and ARB if they have a history of heart failure. So we can use the patient encounter or the patient resource that comes in via the trigger, and we can drill in to that, and we can easily say, the patient is greater than 18 years. And so the way that this rule engine works is it has all of the capability statement built in, and so it's able to dynamically create any of this. For other things that live within the data itself, we create FHIR queries. So this is how we would do a query of a history of systolic heart failure. So we want to say that there exists, and heart failure is a condition that's associated with a code, and FHIR doesn't specify what coding system it is in, but you can specify, say, ICD-10. And I just happen to have a couple of the codes that are defined in ICD-10 for systolic heart failure. You can also use, other coding systems. This depends on how your data is structured in your own system. You can use it to cover, other cases as well. So some, institutions may use SNOMED, some may use ICD-10. And this is what we do. We actually create a query string. And, let's see if I can go back one quick second. Maybe not. But what we do is we create a syntactically correct FHIR query. So if people have tried to build FHIR queries, they know that this is actually quite a difficult endeavor. There's a lot of syntax that needs to be followed and rules. There's quite a bit of debugging that has to happen in order to actually get what you want out. So we've done a lot of the work in order to actually make it easy to create those FHIR syntax queries by sort of, again, knowing how the data is structured. And we do that using a sort of a meta capability statement. All right, so it looks like I'm also running out of time, but I also want to sort of show you that we have a way to build cards as well. Oh, this is starting over from the beginning. So we have a card builder that allows you to create the cards again in, a card is essentially a structured JSON packet. And we have a way to, again, create that using all of the things that are required, what's optional, and build it out. And as you might see, the rules themselves can get quite complex. So, the demo rule I showed you is very simple, but this is one that I coded up, and it shows that, there can be a significant nesting of ands and ors, so you can really actually build out quite powerful rules. This is an example of a prior auth rule. So I will end there because I think I'm out of time and leaving town tomorrow morning. But I'd like to thank you for your time. There are a lot of different use cases. I know this is a really quick overview, but if you have any other questions, feel free to contact me either online or after this. All right. Thank you so much.
On the query builder that you are doing, this data is not live data, right? This data is from specific period of time. Is that correct?
In my
The first
No,
one.
he's
We'll come to the next.
yeah.
The FHIR query builder is reflecting whatever data is in your repository in real time. So it's
Okay.
not copying data. So if you update, if let's say another piece of information, no more resources come in, the analysis obviously is going to be from a point in time.
Right.
But when you go to do the SQL projection, you're going to get what is ever there at that moment in time.
Okay. For the resources that you use, did you use the medication administration resource?
Not,
Or did you use the medication request?
I can't remember. It was synthetic
Yeah,
data.
so medication request is not reflective of what the patient is on because it's only when they are in the hospital at the
Right.
request. And it can be canceled. It can be things like that. So I didn't see that you differentiated
Right,
that.
okay. So the point was really, I may have the wrong resources in terms of the use case. I guess
Right.
that's what you're pointing out. And that may be true, but I want to emphasize that the data that you project
Right?
will be in real time. It's not
Okay.
from the analysis. The analysis phase is just a snapshot in time.
Okay. So it should be reflected real time.
Right,
Okay.
correct.
That sounds good. The second question is part of the presence in the US. Just so when I saw the map, I saw there's a lot of countries all over, but not in the US really.
No.
But you said you are working, your part, Epic is having some components from you as well. So why are you not reflecting that on the map?
Yeah, we have a heavy presence in the United States. Heavy presence in the US.
Okay. You said you're working with Roche, right? I'm from Roche. I just wanted to know the magnitude of the work that you're working with Roche as well, because I wasn't aware that you're working with
Well,
Roche.
yeah, it's because these institutions frequently are so large, like yours,
Right,
that you probably don't know which department we're working with.
right. Well, this is why I want to know, because
Yeah. I think you could count, we could get you that information. I
Cool.
don't have it handy.
all right, sounds good. Thank you. My second question from the gentleman over here for the engine, is it per deployment? They have to deploy it with each tenant? Or does it serve as an outside that can serve multiple tenants?
Yeah, it's outside, so it's a third-party logic engine. So, depending on the deployment itself, it can either be, one instance that if you are a content vendor, say, and you want to have multiple different clients, it can support that, or it can be more, firewalled within your own institution. So it can support either
Okay.
either way.
Thank you.
Hi, I just wanted to know for the FHIR SQL Builder and the Healthcare Action Engine, which version is that on?
The FHIR SQL Builder is not released. It's in beta, and you could get it in the most recent version of 2022.2 will be there, but it will be released for 2022.3. And
Yeah, so one of the complicating factors is that IRIS has their own sort of release things. So they do 4 releases a year, and we do 2. So the Action Engine is on 22.1. And we actually, so it's on HealthShare 22.1, and we're working actually to make it independent of HealthShare. So that should actually be available probably in about the next 6 months to be a add-on kit to IRIS for Health.
Okay, because we just upgraded to 2021.2 for IRIS for Health. So, so are both outside of IRIS for Health, like in its own?
So it's
application?
right now it's part of the HealthShare package, and we can talk further
Okay,
about that
thanks.
offline because it does get a little bit confusing.
Okay,
But
thank
we
you.
can discuss.
There are a few questions that were submitted through Whova. So if you want to answer some of those, we could, or you could respond written to those.
that's fine. We'd be happy to answer if we could. I don't know.
Okay, I can
Can you read them?
read. There's 3 questions. One of them has 2 parts and might be a little complicated. I think I'll start maybe with an easier one. At what scale of data can it perform the joined queries? So that to me is a little out of context,
Yeah.
but
Yeah, for the FHIR SQL Builder, the scalability is very high because essentially we have a very performant FHIR server, and in terms of doing joins, you can index the joined elements to make it a very, very performant SQL query. So yeah, there's no problem with doing joins at scale.
okay. Okay. And then I think we have time for one more question, and then the third, we can respond via Whova. So this question is, do CDS hooks function well for scheduled events or activities in a clinical research cohort? For example, identifying or capturing the required elements, observations needed for a research study visit.
So there's a couple different ways, but yes, you can do that. It depends on how you want to set it up. But for instance, if you want to make a hook that appears, say in an emergency room that determines a patient's clinical trial eligibility, you can certainly write that logic. Depending on how you want to kick that off and display it and who you want to display it to, there can be a lot of different subtleties. We've also done some work that falls a little bit outside of the CDS hook spec itself, but you can make sort of a virtual agent that sort of acts as you can take a list of people, if it's short enough, and actually make individual requests, determine the results of that, and then do notifications based on it. So we can also work a little bit outside the spec.
Okay, excellent. Okay, I think that's all the time we have for questions. So we thank you for your presentation.
Thank you all very
Thank you.
much.